Okay. So that was as much as I could have said in Romanian. For those of you who were in the room, I mean. Um, Welcome to SQL Databases from a dev's perspective. And before we delve into our topic today, did you have a good time yesterday at ITCamp? Good, awesome. Let's give a round of applause for all the sponsors and the great job our organizers did. Awesome, cool. That's great, thanks a lot. So, I'm obviously not Chuck Norris, and I'm not as popular as him either, so it's proper for me to introduce myself. My name is Alex. I come from the beautiful city of Oradea, where I work as a cloud architect and the cloud advisor. Most of my trainings and my consulting usually have to deal with Azure, but back in the days and very deep down, I'm a software developer and a software architect. I also do lots of other things related to Azure, such as authoring for O'Reilly and other big names. And yeah, when you say Azure, that's my thing. It was like 6 years ago or so, or 5 years ago, I came to know Azure. It was this little baby still. I liked it, and ever since then, it has been more or less of a love story. So, enough about me. The purpose of the next roughly 60 minutes or so for today is to tell you a lot about SQL databases. And there are a lot of problems, especially with the naming of SQL databases. And I will try to explain that in the very first introduction, which is going to be a very short part. And afterwards, the plan for me is to literally change your life. And this is no joke whatsoever. So after this session, whenever you will leave the room, my hope is that you'll be just like this. You'll be mind blown. You'll be mind blown by all the advancements that Microsoft did in terms of SQL Server 2016, and especially SQL databases. Hopefully, I will be able to do that. I mean, it's not going to be an easy task, but still, there are so many nice things to talk about. So, as I mentioned, Microsoft, the SQL story, the SQL family, has a lot of different names. And because marketing, and I'm saying this a few times, I really believe this, marketing didn't really do a good job when it came to naming these families. So first and foremost, as you all know, there is SQL Server, which has been around for like almost 2 decades already. That's a very good product. I mean, there is no doubt about that. And then what they're doing nowadays is that they're emphasizing a lot in the idea of installing SQL Server on an Azure VM. And that's more or less like the same kind of thing, but it runs on Azure. And they really emphasize it a lot. I mean, if you read their articles and their blog posts, they have it over there. But then there is this thing called SQL Databases, which I like to put Azure in front of it just to make sure that everybody understands that this is a service which is completely maintained and administered by Microsoft. And there is no maintenance whatsoever. So it's more or less of a platform as a service kind of thing in terms of cloud applications. And you really don't have to deal with all the things which are related to disaster recovery and high availability and so on and so forth. This is SQL databases. Now, why did they do a bad job about it? Because when you want to spin up in Azure a SQL database, you have to first create a SQL database server, which hopefully and thankfully they have renamed to a SQL server. Now, don't be fooled by that, because that's not a SQL server. That's a TDS endpoint, a tabular data stream endpoint. Or more specifically, in other terms, it's a logical SQL server, right? There is no single SQL physical machine dedicated to you as developers, as whatever you are. There is a number of machines. There is replication done underneath it that's completely transparent to you. It just works, okay? It's like any other cloud app. It just works. And then there are things such as Analytics Platform System and Azure Data Warehouse. I'm not really going to talk about this, especially because there's a very cool session. I think it's roughly at 11 o'clock or something like that, so not the one next after the the first one. And that's really going to talk a lot about Azure SQL Data Warehousing. Good. So the purpose, yet again, isn't to do any kind of philosophy at this session. But still, if you think about the theory of which came first, was it the chicken or the chicken egg, It's interesting to make an analogy to SQL Server, because SQL Server is obviously the first one to come, right, in the family of all the products at Microsoft. But here's the catch. So when they came up with the idea of having a subset which is maintained of SQL Server, which would be maintained by Microsoft, they obviously made it as a subset. But what happens today is that because just to make a short trip away, when they made the subset, marketing yet again came along, and they would say they would tell you and like praise SQL databases, that SQL databases, which was still called SQL Azure back in those days, is 95% of SQL Server. You know what? It was those 5% which made most customers not migrate to SQL databases, because it turned out that those 5% were like the most important advanced feature of SQL Server in the first place. And that was problematic. So what Microsoft did at that point was to work around with all these things and come up with new features which they could implement and thus maintain by themselves rather than you, and therefore offer SQL databases. Now, 5 years later, today, what happens is that whenever there's a new feature coming out, they first have a private preview. And they're only adding that service or that feature inside SQL databases, only to SQL databases. After the private preview, when they've already acknowledged all their case scenarios with most customers, because they have some customers in the private preview program, they'll do a public preview, which more or less proves that their statistics and their theories and their pricing strategies are correct. And only afterwards will they go in general availability program. Now, this happens roughly in the terms of a few months. But it's important for you to remember that those months only have the new service or the new feature available for SQL databases. You still have to wait for like a few years for those major features to be added to SQL Server, to the next version of SQL Server. And that's simply because of the cadence. So the pace in which new features or services are added to SQL databases is in terms of weeks, unlike SQL Server, which has its cadence in terms of years. Okay? And just think about it. You create yourself a subscription for Azure, you spin up a new SQL database, and automatically you get all the nice features, all the new cool features added without paying any extra, unlike SQL Server, for which you still have to pay an upgrade license. Now, that by itself is mind-blowing, just when you think about it. From this point onward, I will only talk about Azure SQL Databases, but some features already exist in SQL Server 2016, which is yet to come out as a release to manufacturing product. There are 5 big pillars, and this, as far as I remember, is roughly the last theory part I have in my presentation. From their point onward, it's only going to be demos. So the first thing about SQL databases is that it learns and adapts. And when I say it learns and adapts, I refer to the fact that it learns itself, it learns your application, and it adapts to whatever your application works like. Then there is the idea of scalability, and it scales on the fly. We'll talk about that. There's the idea of efficiency for software as a service developers, about working in your environment and secures and protects itself. Now, obviously, this seems like marketing, so I don't really like this slide. And I will show you a few demos which are really, really cool. In terms of learning and adapting for your application, just think about this. So ignore the slide for a second. Just think about this. You have your databases spinned up in Azure SQL Databases. Your application generates, on average, 5,000 exceptions per day, and that's OK. Now, because Azure SQL Database has a machine learning algorithm which can be either activated or deactivated, it's your choice. What it will do, it will learn that your application, on average, throws 5,000 exceptions per second. Now, if there is a schema drift or a schema update, and all of a sudden you have 5 million exceptions per day, it will tell you, you know what? I think you missed something. And it will tell you automatically, without you looking at stuff. It will tell you, there is something going on which shouldn't probably be there. Then there's performance insight. There's index advisor and actionable recommendations. So here's my first demo. What I'm going to do is that I will show you, yeah, this is the right browser, which they didn't approve for this conference. The first thing I'm going to do is that I will show you a SQL database, which is already running for a few months for one of our customers. This is a demo, so the purpose of this database is not to work as expected, okay? That's something we sort of know. But still, I really want to emphasize on a few things. So the moment I open up the SQL database, the settings blade also opens. And there is something called performance, and this is an update of their UI because it previously was called something else. So inside performance, there are three options. The first one, which I have available, is called Overview. And the moment I click Overview, it will show me a very nice chart, which will tell me how much DTU has my database consumed. Now, how many of you know what a DTU is? Now, DTU stands for Data Throughput Unit. And it's more or less like the horsepower of your SQL database. If you make an analogy to a car, the more horsepower you get, the more performant your car is. It's the same thing here. So the more DTU you have, the more performance you have. But because this is a cloud database, in my opinion, the DTU should stand somewhere around 80 to 90%. Because I shouldn't have anything extra, because I'm just paying for things which aren't really used right now in terms of resources. Obviously, I'm not doing a good job. But without this showing me, I couldn't have known that anyway in the first place. So I have information about is my tier and my performance level optimal enough. That's cool. That's very cool. Not mind-blowing, but it's cool. Now, there is also another thing, which is called auto-tuning. Now, before I show you auto-tuning, I really want to show you recommendations. And when I go to the recommendations blade, it will tell me whether, I don't think that's big enough, so let me just do this crazy other thing. Oh, this looks bad. So, there we go. Inside recommendations, it tells me whether there is anything I should do in order to make my database more performant. So had I been missing any kind of index, or had I had any extra indexes, it would tell me, you know what, that index is extra. And the execution plans, they're not optimal enough because you have that index, you should delete it. And not only does it tell you that you should delete those things, it will even give you the queries you should run to do it. But you know what? Because it can give you the queries, there is also the automation thing. So if I just click on this button, I can tell SQL databases, whenever you find out that I'm missing an index or that I have an extra index, just do it by yourself. Just auto-tune yourself so that you, the database, is as performant as you can be. Now, if you ask me, this is mind-blowing, because it really turns out that this not only is managed by Microsoft, but it can manage itself. I mean, just make an analogy to the SQL Server in the on-premises world, where you really had to run daily jobs to make sure that everything is fine and recreate and rebuild indexes. There is no such thing as rebuilding or recreating indexes. Not only that, but if there would be a necessity or a requirement for an extra index, that would be added automatically. How cool is that? Now, you know what? That's not all. This is not all. There is one more thing I want to show you. So this is a demo database, right? Which has been running for a few days. There are a few things which aren't good. I know they're not good because I've used the application, and there are things which can be improved. But rather than looking at the code, like through the tens of thousands of lines of code, because it's a huge app, I'll just go here inside a website, inside a portal. I'll yet again see the DTU, but then there is this table over here. Now, the table over here tells me a few things. First, this is a top 5 of not performant queries. And this will tell me the query ID, it will tell me how much CPU it is using, how long it ran, for the number of times it ran, for the last, what is this? Probably, today is the 27th, probably the last 2 days or something like that. And let's change this to the past month, just to make sure that the examples are good enough. It will refresh everything. Yeah, there we go. Now this is interesting, because there is a particular query which isn't using too much CPU, but yet it's taking a very long time to execute. And it only ran for like 20,000 times for the last month. Now, why is this interesting? Anyone? Because the CPU isn't like maximum, and still it takes a lot of time to execute. Usually, this tells me two things. Either my I/O is not fast enough, which could be the case, or the execution plans aren't being calculated fast enough. I mean, the optimal ones. And therefore, there are a lot of timeouts in the execution calculation step, and SQL Server will just go on whatever it found to be performant before it turned out with the timeout in the step. Now, this is fairly advanced topic, so I'm not going to cover it too much. But let's just click on this guy. Let's just click on this. And not only do I know that there's a problem with the query, I can even see what the query is. And you know what? There's a common table expression. There are a few joins. There is something ongoing here. If you look really careful, there are a lot of calculations over here done. This can be improved. But I don't have to search for the hundreds of stored procedures which were written just to find out where the problem is. Because SQL Databases tells me that automatically. But let's go back at the table. Now, there is an even more problematic situation. And that is this guy over here, which ran for almost 500,000 times. Now, the moment I see that, I should be told, more or less, that I should implement caching. How else in the world could I know that I should implement caching because this runs too much? There is no other technology or other relational database system to do that automatically for you. This is automatic. I don't pay anything for this. This comes out of the box. This is mind-blowing. And if I just click on this guy, it doesn't take too long to execute. So I will see a fairly simple query. And you know what? This could have been executed and saved in a cache store. Why would I execute, for God forbid, why would I execute this guy so many times? And then there is this query. Now, this query really is interesting because it only executed for like 80 times for the past month, the entire month, and it still took, what, 10 hours to execute. That's not okay. That's really not okay. And it's yet again a problem with the execution param, probably. And if I look at over here, I'll see a bunch of common table expression, lots of filters going on, yet another common table expression. Now, this is a complex query, but it's a poor written query. And if I go over here, I have so many joins. And as you know, the more joins you have, the more combinations for SQL to calculate what the most optimal execution plan is. This is not a good job. It's complex. If somebody looks at it, they will be like, oh, hell with that. I'll rewrite this. It's complex, but it's not okay. And the fact that it's not okay is simply shown by this thing over here. And you know what? Most systems will tell you how much CPU or how much RAM is your SQL Server using. Had I ever looked at the CPU or at the RAM or at the I/O, that wouldn't have told me anything. Because this isn't using too much CPU. This isn't making too much I/O on my hard drives. And still, because of SQL databases, I know it's not a good query. That's cool. That's very cool. Now, I really hope you're mind blown by now. Let's move on. Scales on the fly. Now, there won't be a demo on this, but just think of it. Just think of it for a second. So if you know you'll have a Black Friday offering next week, normally on the on-premises world, what you'd normally do is that you'd start up a new project, you'd file some papers with your financing department inside your company. You'll have long procurement days. You'll have new disks coming in. You'll install all those disks in a write probably. You'll spin up new nodes in the cluster. You'll do all kinds of crazy things. You'll add a new node to your always-on cluster and stuff like that. That takes time, right? And the moment the Black Friday offering is done, you only have these machines over there which are idle. So you're literally paying for machines to run and do nothing. Now in SQL databases, just go to the website, You drag a small slider, you have more performance. The moment you're done with your Black Friday offering, you go back down. You know what? You pay by the minute. The more performance you want, the more you drag the slider, the more you pay, obviously. But then again, you just drag the slider back down, and you no longer pay so much. That's cool. That's very cool. But there's one even cooler thing. And that is the fact that in the cloud world, so the holy grail of the cloud world, is the fact that your application will eventually be a multi-tenant application. You won't reinstall your application over and over and over again for each and every single one of your customers. You'll have a single application, probably a multi-tenant application, but you probably will also have multiple databases to completely isolate the data from one customer to the other. And that's an interesting fact. But you know what? In SQL databases, there is this thing called elastic database pools. So just think of a scenario where some of your customers are based here in Romania, and they will use the application throughout the day, right? Your other customers are based in the US. It will be nighttime when in Romania when they will use the application. You can just add all the databases in something called an elastic database pool, which will represent the number of performance, the number of DTUs you will have throughout all the databases altogether. And that literally means that your databases, even though they won't share any data or even any schema, will share the same hardware, underlying hardware resources for the entire logical SQL server. And that again, this is not a SQL server, this is just a TDS endpoint. This is cool. This is very cool. Because in the on-premises world, there is no such thing like this. This is completely new, completely mind-blowing. There is nothing like it. Now, it works on your environment, and this is yet again more or less obvious. So there is a single language, T-SQL, which you know and love, hopefully. It works with all the platforms. It works with all the tools you already know. If you ever bought licenses for Redgate, for continuous deployment, for SQL Compare, for whatever, they still work, and that's cool. That's very good. Now, you know what? SQL Databases also protects and secures itself. And you might be asking me, what's that all about? How can it protect itself, right? Let me show you. Let me show you how it can protect itself. And this will be cool. So I hope you're all ready and fired up. So this is a web application I wrote. It's a demo web application. I'll give you that, right? The moment I will run my web application, here's how it works. If I log in with successful account with the correct username and the password, I will see a list of customers, the customers of my company. If I don't log in with the correct username and the password, I will not see the list of customers. Now, some of my developers, they know that it's not good to tell you whether the username or the password is incorrect. They know that it's a good option to just tell either the username or the password is not good, but I'm not going to tell you what. In this demo application, they're not telling you anything. It's just like you type in a few things, you try it out, and it won't do anything, right? It's super secure. But there's a thing. You know what developers usually do when they have to check the username and the password? They'll do something like select whatever, doesn't really matter, where username is and password is. Now, some developers, they're smart people, and they have learned that you need to use parameters. Now, here's the thing. Not all developers, unfortunately, understand that the parameter should be a SQL parameter. And because they know C#6, which is cool, and what they're doing is they're not doing a string format, but they're doing more or less something like this, right? Select from wherever, doesn't really matter, where the username equals, and there's a placeholder for the username, and one for the password. So far, so good. Or is it? Now, here's what I'm going to do. First, I'll just open out Outlook, because maybe I get an important email somewhere from Uganda telling me that I want something if I just inherit somebody's money. Here's what I'm going to do. So I'll just try out a username, a random username. Does anyone want to say what a username could be like? Come on, anyone? Joe. Joe is a great username. Now, for the password, I'm a smart guy. I want to see the list of customers for this company. Here's what I'm going to do. I'm going to write this, and then I'm going to write or 1 equals 1, and then I'm going to do this. What does this thing do? It's a smart thing. It's a smart thing. So there was where username equals blah, 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 and password equals. And I will stop password, and I will just add or scratch that equals 1, hopefully, and comment out the rest. You know what? I'll log in. Now, this isn't a new technique. This is called SQL injection, which you probably already know, hopefully. This has been around and still is around for the last decade or so, and still is in top 10 OWASP. But SQL Database protects itself. It did show me the data, but here's what it did. It will send me an alert, an email, automatically. And you saw the email coming in. I'll just open this guy, and it will tell me, hey, Alex, there's a problem. There's a potential SQL injection detected right now on that database at this time. And if, you know what? I can even click on this guy over here, but because this is under preview, it doesn't really work. And I didn't just say that. And it will even show me the exact query. Now, I will still show you the query, because there is a workaround. I'll just go to all the information for the audit logs are stored inside an Azure SQL account. Sorry, in an Azure storage account. Let me just refresh this guy, and it will show me all the queries which ran on a particular database. The database is called demo inject. It takes apparently a few seconds, and there we go. And we should have somewhere around here our select. Select something from there. It's somewhere around here. It might take a little time for it to show up, but it's somewhere around here. Where is it? Anyway, you get it. There is one. There is one here, right here. So not only do I get informed, but I can even see what the attack method was and what exactly the hacker typed in. And you know what? Yet again, I'm not paying for this thing. It's done automatically by SQL databases. And if you ask me, this is mind-blowing, because there's no other technology to do that automatically without paying extra license for it. So, cool. But you know what? This is not enough. I want more. I really want more from it. Because I told you, I will try to mind-blow you. So this is not enough for that. Here's what I'm going to do next. I will stop this demo, and I'll just think of another scenario. And that is prepared right here. So here's what I'm going to do. In this demo, the idea is that you probably have seen this already in certain websites where you type in your credit card number, and when you look at a list of credit cards you have associated to your account, there's like an XXXXXXX, and then you see just a few numbers. That's a security thing. You can do that by yourself within your application, and it's fairly easy to implement, right? But there's still a lot of code to write. And the actual problem is that you're storing something and you have to show something else. So then you have to implement either on the application layer or on the store procedure layer, on the data layer, some way for this masking to work. Now inside SQL databases, this is called dynamic data masking. Inside this demo, I'm just showing out a list of customers. Now here's what I'm going to do. I will go to the website, to the portal, to the Azure portal. Where is that? Here it is. And I'll just say that on the database called, where is that guy? Called this database. I'll just go to the settings blade. And rather than implementing all this crazy code, which has to be tested and tried out, I'll just go here. And I'll tell it, you know what? I want to activate dynamic data masking. And not only that, but I will also want to do it for, here's the cool thing. So I'm in the portal, and it also it automatically shows me the schema of all my tables. This is nice. This is nice. So on the customer tables, I will just add a mask for the first name, because I don't want people to be addressed, my customers to be addressed by their first name. And if I so like, I can just go in and change the way this will look like, and I will tell it, you know what? I want the first letter of the first name to be shown. Then I want a bunch of fixes, 3 X's. That's okay. I'll just update this guy. And now I go to my website, I click refresh, and there we go. Or not. It's still loading. It's still loading. First name, customer. Did I miss something? First name, customer. This might not be the correct database. Just let me check. Demo gods are not on my side, apparently. ITCamp, demo DDM. It's still the same correct database. I also have one for the email address, which, yeah, the email address is working. Doesn't work on the first name field, though. Yeah, you get the idea. And that's the important part. I'll delete this and I'll add it again. So customer, this is customer. Let's do it on the last name as well. I don't want to exclude anyone. I'll just save. Did I hit save before? I didn't. Oh yeah, that's the thing. I didn't hit save. You have to hit save, Alex. And there we go. Last name is masked. And that was all I had to do, rather than do any crazy other amounts of things and write incorrect or buggy code. And that's cool. That's very cool. But you know what? You might ask yourself, what's with all this mumbo jumbo about using a website to do stuff and implement policies inside SQL databases? And here's what I can do. I can just go to my database from within SQL Server Management Studio. And what I'll do next is that I'll just alter the table. And there is this new keyword called add masked. I'll just add the mask for, let's say that I want to add it this time for the first name, because that didn't work first. I forgot to save. And I'll just say, you know what? I want a bunch of asterisks to be shown. I'll execute this guy. Obviously, I have to connect. This won't work. This won't be the correct initial catalog. OK, almost there, almost there, almost there. Execute, and we're done. Refresh, first name, and it works. Cool, cool. That's nice. That's impressive. But you know what? There's one certain scenario where probably for your admins, you still want to show the entire data. Turns out that this, by default, works with the default policy you define by yourself. And what I did here is to use a specific user, which isn't the administrator. But the administrator is still connected, so the connection, the TS connection, is created with an admin account. An admin account meaning what? This admin account, obviously. And if I query the data with that account, I still see the full name and the full last name and the correct email address and so on and so forth. I didn't write a single line of code for this. It just works. Now, this is impressive. I can delete everything, obviously. And I'll just delete these two, and that's OK. But there is another certain scenario which I want to think about. And the other scenario is, what about situations where within your company you hire a new sales guy? Now, hiring a new sales guy, I'm a technical guy. I don't like that. You know what? There's a thing about that. Sometimes when you hire a new sales guy, there is a risk for the sales guy to sell the entire database of all the customers of the company. Now, how do you prevent that? Well, you obviously implement policies for that sales guy not to be able to see all the customers' database and the list of all the customers the company has and how much revenue they have from them and so on and so forth. I can implement that, right? I'm a smart guy. I'm a very smart guy. I can really implement. I can write a lot of store procedures, a lot of SQL code. I can implement it on the application side, but if I have multiple applications, I have to rewrite the same thing over and over again. It would work at some point. There's something which is super, super, super cool. I'll just close this guy. Let me quickly connect these as well. Oh, I don't want that. Crazy thing. Come on, do it. What's that? does not have access to the server. Did somebody just change my IP address? That's crazy. But you know what? That can happen because I'm on a shared connection here. I didn't really want that to happen right now. So I'll just quickly go to the server, open the settings blade, there we go, firewall, add a firewall connection to my client IP address. Yeah, my IP address changed. Cool. I was hoping for that. Not. So here's what I'm going to do. I'll connect to this guy as well. I'll quickly change the connection to be to another. Oh, that's not a good one. That's not a good one. Sorry for this. Totally not scripted and not expected. So remember the demo and the scenario I've told you about. I'll open up this application now. I'll close this one. I don't need this one anymore. I'll open this demo right now. So here's what I'm going to do. I'll run the demo, and as a new, I will register as a new sales guy, fairly fictional sales guy for FabricCam, if you so like. Let's just wait for it to spin up and to load. Come on. There we go. Let me first log off. I'll register. This is yet again an MVC application. What should the name of the sales guy be? Come on. Mike. That's a great name. Mike at contoso.com. Now, I'll just type in a password. Doesn't really matter which password it is. And I'll do the next thing. So I'm registered. The moment I'm going to register, it will take me to the customers. I can go to the customers list. So just say type in customers. There we go. And yet again, here should be the list of customers. Come on, show it. Great. Now here's what I'm gonna do. First, I will say that I want to see the list of customers. And inside my table for customers, there's something called the user ID. Now, this is the user ID which is associated, the sales guy, which is associated to the particular customer, because this is the header information about the customer. Good. Let's just say that let's also query the table called in the DBO schema ASP.NET users. I just registered with a new account, Mike. There we go. This is the unique ID, the global unique ID of Mike. And I will say that for the first 5 customers, that's okay with me. Just save this particular user ID. So the first 5 customers are Mike's customers. Now, normally at this point, I would have to write a lot of code, a crazy amount of code. Like, what I'm going to do is that we'll just run these things over here. The first one creates a schema. This is a best practice. I will create a schema called security, and I'll add to that schema a function. And I will explain what this function and this new keywords do in a second. So the schema itself will use a session context. What is a session context? Who knows what a session context is? This is a new thing for T-SQL as well. This has only been added right now, recently in SQL Server 2016. So have you ever heard of a context info? Context info in SQL is a way for you, context info T-SQL, there we go, is a way for you to save information within the context, within the session. But there's a catch with this. You can only save like one thing, right? There isn't a key value pair association or something like that. There is only one thing. Right, so this makes it fairly complex because you have to use probably something serialized, convert it to a byte, de-encrypt the byte, or deserialize the information from the JSON file, and you eventually have information per session. Now, because this is too much work to do already, they have added this session info thing, where you have a key value pair, more or less. Just think about it as a key value pair. Now, whenever I log in my ASP.NET application, I will tell my application that, hey, this is the current user's ID, okay? Good. And whenever this function will be triggered, it will check whether the parameter which was sent is the same as the one saved inside the session context. I will show you where the session info or the session context info is saved in a second. Now, when is this function called is the first question. The function is called whenever a security policy is required to be evaluated. Now, there are two things here. There's a filter and there is a block. The filter is here to limit the read access to rows, whilst the block is to limit adding new rows to the database with other users. So the scenario would be me adding a new customer and telling people, you know what, this customer who doesn't pay the invoices is dense customer. That's not okay. So I have these two predicates. Predicates is yet again a new thing. That will tell it whenever this runs, just run the function. Did I run this already? I don't remember. Did I run it? I don't remember running it. I did? Okay. If you say so. Hopefully I did. Now, inside my application, I implemented something called an interceptor. Now, an interceptor is exactly what the name says. So whenever there is any SQL operation, I will configure this store procedure, system store procedure to run, and it will say just set session context where the key is this thing and the value is this thing, okay? And what is gonna happen is that, let me actually add a breakpoint here. What's gonna happen is that, here it is, when I refresh this guy and go through this thing, the user ID will be obviously the user ID of Mike. I'll just leave it running, and there you have it. Without running or without creating very complex store procedures, without creating very complex code with my application to check policies and firewalls and stuff like that, it just automatically works. And that's cool. But you know what? There's another thing. So previously, I had more or less of a policy based on the SQL login. So had it been dynamic data masking login, then I would mask things. Had it been the other thing, then I would mask it as well. Now, because in this situation, I'm no longer relying on the SQL login, if I run the same query within my connection from SQL Server Management Studio, I obviously don't see anything because I'm a DBA. I shouldn't see any information related to customers because it's not my job. And this just works because it works on the server level, not on the client level. This is very cool. This is very, very cool. Otherwise, had it been a stored procedure, the DBA still would have had access to the entire list of customers. Now, you know what? Let's go a little further. So what just happened? I've shown you how you can mask attributes based on given pattern. I've shown you row-level security. There's another thing called always encryption. I'm not really going to delve into that one, but here's the thing. Inside always encryption, the thing is that your application relies on an enhanced ADO.NET library. So whenever there's a new call done, this enhanced library will make the call, will encrypt some information, will make the call to SQL, which will match the information. It will send out the encrypted data yet again, and it's yet again the enhanced ADO.NET library to decrypt the information. This is very important, because only now can you really rely on the fact that the data is encrypted without storing the encryption keys and certificates and so on alongside with the database. Instead, they're stored somewhere else, and it's either on the client level or inside Azure Key Vault. This is cool. I'm not going to do a demo because I want to show you something else. And that is, I'll skip this part. That is performance. So what they would normally tell you, and it is correct, is that by simply updating to SQL Server 2016, you'll get huge performance levels, such as 1,000% faster, 2.5 times faster, stuff like that, by the major companies. And you know what? You don't have to take the word for it. I'll show you a few things right now. They will also tell you that there is non-volatile memory support, both with blocks access and direct mode access. This actually has to do with SSD disks. Let's show you something else. And it is called in-memory OLTP. How many of you have ever used in-memory? Good. You're the greatest audience ever. That's exactly what I was expecting, honestly. So here's what I'm gonna do. I don't need this guy. I have an application opened up here, this guy. And what this application does, it tries to stress out a SQL database. And by stress out, I mean sending out a bunch of queries a bunch of times. Those queries will do a lot of inserts. And not only that, but I will open up the same application multiple times so that I have multiple connections open concurrently. You can see here that whenever I open the new connection, I'll just read an argument. The argument represents the number of times I want this query to run, and the query itself is, where is it? This guy. And this guy is defined as this thing over here. And it does a bunch of inserts and then executes some stored procedures, user-defined stored procedures. Now, the first thing I'm going to do is that I will run this thing. And just take my word for it, as I will show you in a minute what this thing does. Let me open the Storage Explorer. There we go. Windows Explorer, sorry for that. I'll copy this. Actually, let's do it again. So it's proof that this is correct. I'll rebuild the thing. I will copy this. Why do I copy it? Because obviously the network connection isn't reliable and I want to stress things out. I can't rely on a network connection from here over to Dublin. I have a VM ready in Dublin. Let me just open the RDP connection to the VM. I will paste the application. There it is. And let me just show you the bat file. So the bat file will just start the executable file. It will send out 15 meaning I want you to run 15 times the same query, same inserts, and also the execution of the stored procedures. I will run this guy. Come on, start. There we go. It runs. The number of copies I have is a lot. 64. So it's 8 times 8. It's 64. And I will wait for it. The moment it finishes, it should show me how long it took for it to finish. And there are a lot of things. So whilst it's still running, let me show you what I did to have those stored procedures created. Now, there are two situations. First, actually, let me show you the schema. So besides expanding, that's good. So besides the normal tables, there are some tables which are suffixed with in-mem and on-disk. And it's both for detail and header. On-disk is more or less of a copy to the other one. In-mem is something more powerful. Now, right now, everything runs on disk, like almost all SQL environments run. When I run on disk, I have to wait for a while. Oh, cool. Why did this happen? Oh, let me think for a second. Why did this happen? Come on, close. This is exactly not what I expected. This was running an hour ago. In-mem, you know what? I'll do one more thing. Bear with me. Bear with me. I'll just open up the firewall for anyone, because this is really pissing me off, honestly. I'll just open up the firewall for everyone. Good. Let's just save this thing. Let me check in-mem, on disk, that's good. That's very good. Rebuild the thing, zoom in, should still have run. Oh, not do. Sorry. I'll replace the thing. Let's run it again. Did you notice anything I was missing? You didn't, right? Show them side by side. Do it. It should run normally. Let's just check that the tables are correct. They should be okay. I mean, it was running. Web config, there should be somewhere. Yeah, that's good. Demo is inc. Yeah, one of those guys already finished. Why did this guy finish early? Because of the batch file that actually ran faster than the rest. So that opened up a connection way faster than the rest of those. Again, this is killing me. The others ran. Jesus, let's just look at this thing. It says, doesn't say anything good. Time that expired. Server not responding. Are they having problems? Now, here's what would normally have happened. This would have taken actually roughly 2 minutes or so to execute. And after that, I would have opened, and I'm really, really sorry for this, because this really ran. I'll close all the guys. Afterwards, I would have just gone here and change, not here, sorry, here, and change this thing into inmem. And the moment I would have changed it to inmap and rebuild all the thing, and then open the folder, copy it yet again, this is what I would have done. Let me close the thing again. I would have pasted this thing, which would have executed in mem this time. And this would have normally have taken roughly like 7 seconds. Not 2 minutes, but 7 seconds. And this is just by doing a small change, and that is use in mem. This is blazingly fast, and it's support inside SQL databases, so you no longer have to install a crazy amount of memory inside a on-premises server. But they're obviously having problems. It's still in beta. I have to admit that. It's still beta. Oh, I'm so sorry about this demo. This killed everything, and it also took too long. Yeah, this is too bad. I feel so sorry about it. Now, I still hope you got the idea. So, I'll skip temporal data. No time to do that. Hopefully, I was able to show you a few things, not the not running demo, which would have blown your mind. But the other things were really, really cool, and this is also cool by itself. There's still like 4 minutes left for questions. There's a question.
So you said there are index advisors.
Yeah.
For example, are they always predict the right index you have to add or to remove, or it just crashes sometimes?
So because of the recording, I will have to paraphrase you. The question was, does Index Advisor always predict the correct index which is missing? It does a good job. And I think that answers your question. Is there any other question? There's another one. Cool.
There are some charts which shows you if the queries are slow.
Yeah.
Are these charts customizable? Like you can add thresholds, or they show you what they predict?
There are a few things you can customize within the charts. Okay. So the ones you've seen in the portal, right? Yeah, there are a few things which you can customize. In terms of threshold, though, what you could also do is create your own alerts, so that whenever your DTU reaches a certain amount, or only the CPU by itself, or only the disk I/O by itself reaches a certain amount, it will tell you and it will send you either a webhook, which is cool, or an email to whatever email address you want. Yeah, and that usually, honestly, that usually helps a lot. Because if you have something running and you think it's running okay, you just get this notification on your phone whenever you're the most busiest, usually, because it's like the Murphy Law, and which tells you, you know what, you have to do something with the database, maybe scale up because it doesn't work as expected. Yeah. you can do that.
And something else, if the query runs too slow, we have to implement some cache. Is this cache implemented by Azure, or do we have to?
No, that's on your side right now. So you have to implement it by yourself. There are some offerings inside Azure, which are good, which are really good. One of those is the Redis cache, which is literally taken the Redis cache you know and love, and they put a REST API over it, and they're offering you that cache. It's obviously a paid service, but it still runs very good. You don't have to worry about clustering and stuff like that, because it does all the things which you should do. You only tell it, I want this amount of memory, I want this amount of clusters, and you're done.
Thank you.
Thanks. Any other questions? Well, if not, I will still be around for other questions offline. Thanks a lot. Have a great second day at ITCamp, and don't forget to fill in the feedback forms, because you can get those cool parrots. Thank you.